Let's solve this problem together. What would be the freezing point of a saturated solution of caffeine in water if it takes 45.6 grams of water to dissolve 1 grams of caffeine? And we're provided with the molecular weight of caffeine and the Kf values of H2O. First, let's review the concept of freezing point depression. So freezing point depression is this phenomenon when you dissolved a solute in a solvent to create a solution. Then the freezing point of the solution is lower than that of pure solvent. So if you have TF solvent as the freezing point of solvent and TF solution as the freezing point of solution, then you'll always have TF solution smaller than TF solvent, and you also have something called delta TF, or the freezing point depression, and that is simply the difference in freezing point of the solvent and the solution. So we'll keep that in mind right here, and we'll also have the formula to calculate delta TF, that is taking Kf, or the molal freezing point depression constant, times the molality of the solution. So let's go straight into solving this problem. In this problem, we have a solution consists of 1 grams of caffeine dissolved in 45.6 grams of water, and we are asked to find what is the freezing point of this solution. So we know that we can find the freezing point of solution by taking freezing point of solvent minus delta TF, or the freezing point depression. We know that in this problem, the solvent is water, and the freezing point of water is 0 degrees Celsius. So to find the freezing point of the solution, all we need to find is the freezing point depression, delta TF. So to find delta TF, we know the formula to calculate delta TF is taking Kf times molality, and if we expand on that, we'll have Kf times mole of caffeine divided by kilograms of water. So we can start plugging numbers in. We know the Kf value is 1.853, and we can calculate the mole of caffeine by taking mass, 1 grams, divided by the molecular weight of caffeine, which is 194.19 grams per mole, and divided all of that by kilograms of water. We have 45.6 grams of water times 1 kilograms over 1,000 grams to convert to kilograms. So after calculating all that, we'll get 0.209 degrees Celsius. That is delta TF. So once we got the freezing point of solvent is 0 degrees Celsius, and the freezing point depression, delta TF, is 0.209 degrees Celsius, we can go ahead and calculate the freezing point of this solution. Simply plugging numbers in, we got 0 minus 0.209. That's going to give us negative 0.209 degrees Celsius. That is the freezing point of this solution, and that's the answer to this question. If you're interested in more practice problems on this topic, please consider purchasing Easy Chemistry worksheet on colligative properties of solution. You can also get the worksheet for free by subscribing to Easy Chemistry YouTube channel. Details is in the description. Check it out. Thank you for watching.